Three things are hitting America all at once, and the timing could not be worse. As of this morning, June 22nd, 2026, 27 uncontained large fires are actively burning across the United States. Seattle is bracing for temperatures that could challenge records set in 1992, and floodwaters are still rising across the Gulf Coast and the Ohio Valley after one of the most extreme rainfall events this country has seen in years. This is not one weather story. This is three separate crises colliding at the exact same time, and your area may be directly in the path of at least one of them. Today, I am going to break down every single one of these threats in full detail. I will walk you through what is happening right now, today and tomorrow, then take you through the complete 7-day outlook, then step back and explain the massive atmospheric signal that is driving all of it simultaneously. And at the very end, I am going to tell you what the models are signaling about potential tropical development in the Gulf Basin, because that story is just beginning to develop, and it could become the biggest weather story of the week by the time we get to next weekend. Stay with me. This is a lot, and every single part of it matters for someone watching this right now. My name is Arthur, and this is Sky Space Lab. If this kind of real-time, data-driven weather coverage is what you come here for, hit that subscribe button right now. We post every single day when conditions are this active, and this week is shaping up to be one of the most active multi-threat weather weeks I have tracked in all of 2026. Let's get into the data. The first thing I want to hit this morning is the wildfire situation, because the numbers coming out of the National Interagency Fire Center are unlike anything we have seen at this point in a fire year in a very long time. As of June 18th, just 4 days ago, 27 large fires are uncontained across the United States. That figure came on the heels of 74 new fires igniting in a single day. More than 4,900 firefighters, dispatchers, aviation personnel, and incident management teams are currently assigned to active incidents from coast to coast. The national preparedness level was elevated to 3 on June 18th. On a scale of 1 to 5, a preparedness level 3 means geographic areas are increasingly unable to meet their own resource demands, and national support is being called in to sustain operations. This is a national crisis, not a regional one. Here is the number that should stop every one of you cold. 33,349 fires have burned more than 2.6 million acres in the United States so far in 2026. That is nearly 200% of the 10-year average for this date. We are burning at double the historical pace and summer has barely started. According to AccuWeather, the full-year forecast for 2026 calls for 65,000 to 80,000 total fires, burning between 5.5 and 8 million acres before this season ends. That is a potential 8 million acre fire year. CAL FIRE has confirmed that flash drought conditions are developing across Northern California faster than historical models predicted. In Southern California, persistent drought, high grass loads, and a weakening coastal marine layer are building toward conditions that fire scientists describe as explosive and potentially unprecedented for July and August. What does the active map look like right now? In the Pacific Northwest, 4 major fires are actively spreading in Washington and Oregon: the Carter, Rosa, Cable Creek, and Tucannon fires. Evacuations are in effect near those perimeters. Road closures are impacting travel. In the Great Basin, new fires in Idaho and Nevada, including the Median, Cane Springs, and Grapevine fires, are showing rapid growth with what managers call challenging fire behavior. That phrase matters. It means erratic wind-driven runs that can outpace any ground crew response before they can establish containment lines. In the southwest, the Sycamore Fire in Arizona and the Bear Fire in New Mexico remain active. On the plains, the South Fork Fire in Nebraska has burned more than 39,000 acres. Here is who needs to watch this the most in the next 48 hours. If you're in eastern Washington, northern Idaho, northeastern Oregon, northern Nevada, southern Arizona, or western Nebraska, fire conditions are at their most critical level today and tomorrow. The offshore flow pattern this week is creating what meteorologists call the hairdryer effect across the east slopes of the Cascades and the Rockies. Air descends through mountain passes, warms and dries as it loses elevation, and arrives at the surface already hot and moisture depleted. In parts of eastern Washington today, relative humidity values are dropping into the single digits. Fire scientists call this extreme fire weather. A single spark from a power line, A vehicle, a campfire, or even a piece of equipment can produce a fire that expands faster than any response team can match when you're sitting at 8% relative humidity with winds gusting to 30 or 40 miles per hour. Most channels are not showing you this part, but it matters. The smoke from these fires is not staying local. Air quality alerts have been issued across more than a dozen states, as wildfire smoke from western fires and Canadian fires drifting southward has pushed fine particle pollution, PM 2.5, to levels that are unhealthy for sensitive groups, and in some areas unhealthy for everyone. A UCLA study published in early 2026 estimated that wildfire smoke kills more than 24,000 Americans every single year. More than murder, more than any other category of air pollution. If you are under a smoke advisory, an N95 respirator is the only mask that meaningfully filters fine smoke particles. Surgical masks and cloth face coverings do not provide meaningful protection from PM 2.5, and if you have children, elderly family members, or anyone with heart or lung conditions in your household, keep them inside with the windows closed and air filtration running when air quality drops to unhealthy levels. Let me go deeper on the wildfire numbers, because I think most people, even those living near active fires, do not fully understand the scale of what is happening nationally right now. The 62% of the country currently in some form of drought is not evenly distributed. The most severe drought conditions are concentrated exactly where the fires are burning, across the West, the Great Basin, the Southwest, and the Northern Plains. The US Drought Monitor shows exceptional drought across parts of New Mexico, Arizona, and the Southern Rockies. That is the highest category on the drought scale, the kind of drought that takes years of above-normal rainfall to fully recover from. Meanwhile, the vegetation that has been dying under this drought, the grasses, the shrubs, the timber, has been curing and drying for months. Fire scientists measure this dryness through what they call energy release components and Keach-Byram drought index values. Both are running at extreme levels across the fire zones right now. What this means practically is that any wildfire that ignites in these conditions has what fire managers call a high rate of spread. It moves fast, it moves unpredictably, and it produces firebrands, burning embers, that can travel more than a mile ahead of the fire front and start new fires before the main front arrives. Communities that believe they have time to prepare when they see smoke on the horizon may find that assumption tragically wrong in these conditions. If you are in an area with current fire activity or high fire weather conditions, your evacuation bag should be packed right now, not when the alert comes, right now. The smoke picture adds another dimension to this. Beyond the immediate health threat of PM 2.5, wildfire smoke this season has been documented spreading across the eastern United States into Ohio, Pennsylvania, New York, and New England on multiple occasions already. People in Cincinnati, Pittsburgh, Baltimore, and Boston have experienced hazy skies and degraded air quality from fires burning thousands of miles away. The jet stream carries smoke particles across enormous distances. The same El Nino pattern that is building western heat domes is also shaping the upper-level flow that determines where smoke travels. This is not just a western issue. The environmental consequences of this fire season are national. But fire is only one of the three things hitting America right now. At the exact same time, flooding is devastating a completely different part of this country in a completely different way. And the rainfall numbers from the Gulf Coast over the past week are almost impossible to believe. The remnants of Tropical Storm Arthur, the first named storm of the 2026 Atlantic hurricane season, delivered rainfall totals that shattered regional records across the central Gulf Coast. In Cotton Port, Louisiana, 31.56 inches of rain fell in approximately 24 hours. That is nearly 3 feet of water from the sky, in a single day, in a single location. Louisiana Governor Jeff Landry declared a statewide emergency, citing widespread flooding and severe storms across the state. Parts of Louisiana received more than 20 inches of total rainfall, according to the National Weather Service. Water rescues took place through the night in Seminary and Sanford, Louisiana, where homes and businesses were taking on water faster than residents could evacuate. Flash flood emergencies were declared across multiple Gulf Coast parishes, and the National Weather Service issued a rare Level 4 of 4 flash flood risk, the highest designation in their flood risk system, for southern Mississippi, southern Alabama, and the western Florida Panhandle. Historically, 1/3 of all flood-related fatalities, and 80% of all flood-related damages occur in areas under Level 4 designations. One person was killed in Mississippi directly as a result of this event. In Dallas, a flash flood warning escalated to considerable status with rainfall rates of 2 inches per hour and at least 4 accumulated inches already on the ground in the city. Multiple roads in downtown Dallas were impassable under high water, especially under overpasses where water pooled rapidly. Harrison County, Mississippi saw vehicles fully submerged in floodwaters. On June 19th, the NWS issued a Level 3 flash flood risk, still highly dangerous, for parts of Louisiana, Mississippi, Alabama and the Florida Panhandle, as rainfall rates of 2 to 3 inches per hour remained possible. A flood watch extended from eastern Louisiana all the way through central Georgia. Here is the key detail that changes how you need to think about flooding risk for the rest of this week. The Illinois and Wabash rivers are seeing minor to moderate flooding right now. Water levels on the Mississippi River are elevated and rising, and across an enormous swath of the South, from Louisiana through Georgia, the soil is fully saturated. When soil hits saturation, it loses the ability to absorb additional rainfall entirely. The next storm system that moves through, even a modest one that would normally drop just an inch of rain, sends that water directly to surface runoff, then to streams, then to rivers, then to streets. Flash flooding can develop in 30 minutes or less in saturated conditions. If you are in Louisiana, Mississippi, Alabama, Tennessee, Georgia, or the Carolinas right now, you are living in a saturated landscape. Turn on wireless emergency alerts on your phone if you have not already done so. That is your fastest warning when water starts moving. So what does the NWS say is coming in terms of additional flooding through the end of the week? AccuWeather's latest update as of June 21st shows rounds of heavy rain and flooding continuing from Texas to northern Florida, Georgia, and the Carolinas through early this week. A general 1 to 4 inches of rain will fall across these areas, with locally higher amounts to 6 inches in parts of the Ozark Mountains in Arkansas, and the southern Appalachians in Georgia, North Carolina, Western Virginia, and West Virginia. Thundery downpours will keep the flash flood threat active through at least Tuesday of this week. If you are in any of these areas, the rule is simple: never drive through flooded roads. Turn around, do not drown. It is still the #1 cause of flood-related deaths in the United States. Let me stop here and ask you directly. Drop a comment below right now and tell me which of these 3 threats is the one your community is most concerned about. Are you watching wildfires? Are you dealing with flooding damage? Or is the heat the thing that is keeping you up at night? I read every single comment and your answers help me shape tomorrow's coverage to reach the people who need it most. Now let's talk about the 7-day outlook starting today, June 22nd, because what is happening with temperatures across the Pacific Northwest this week is extraordinary. Seattle is in the middle of its second heat wave in under 10 days. AccuWeather confirmed as of June 21st that Tuesday, June 23rd is expected to be the peak of the heat in Seattle, with a high in the low 90s. That challenges daily records from June 22nd through the 24th, all 3 of which were set during the same 1992 heatwave. Portland reached exactly 100 degrees on June 22nd, 1992. Current forecasts put Portland coming within a few degrees of that mark today. An extreme heat warning is in effect for the Portland Metro and the Columbia River Gorge through Tuesday night, with temperatures expected to reach 95 to 100 degrees. A heat advisory covers much of the rest of the Pacific Northwest through at least Tuesday. The mechanism driving this heat is a strong upper-level ridge that has planted itself off the coast. Air sinks beneath it. Sinking air warms as it compresses. Clouds cannot form because sinking motion suppresses all convective lift. The sun cranks down on the surface for days without any cloud cover to block it. In the Cascades foothills, the same offshore easterly flow that is driving fire danger creates what forecasters call the hairdryer effect. Air descends through the mountain passes, warms further through adiabatic compression, and arrives at sea level already hot and dry. The result is temperatures that can run 15 to 20 degrees above normal in communities that have very little air conditioning infrastructure. KIRO meteorologist Ted Buhner, who spent decades at the National Weather Service in Seattle, said publicly last week that ECMWF runs were showing 850 millibar temperature anomalies over Puget Sound of 14 to 16 degrees Celsius above normal. That is a significant signal. For reference, the catastrophic 2021 Pacific Northwest heat dome ran 16 to 20 degrees Celsius above normal at the surface at its absolute peak, when Seattle hit 108 degrees and hundreds of people died across the region. We are not at that extreme yet, but this is not a normal heat wave either. Wednesday, June 24th should bring some moderation to the northwest, as the ridge weakens slightly and a marine influence tries to push inland from the coast. But the heat does not vanish, it shifts east and south. Thursday, June 25th through Saturday. June 27th brings temperatures of 105 to 112 degrees back to the desert southwest. Phoenix, Tucson, Las Vegas, Palm Springs, Yuma. Daily records will be at risk during this stretch. By Friday and Saturday, above normal heat spreads broadly across the southern and central plains. In Kansas City, Oklahoma City, Dallas and Houston, 95 to 100 degree heat combines with dew points in the upper 60s to produce heat index values that can reach 115 to 120 degrees. That is dangerous territory for anyone working outdoors. When GFS and Euro agree on something like this, you pay attention. Both models are showing a persistent ridge anchored over the southern tier through at least the final days of June. The WPC's latest guidance confirms above normal temperatures for the central and eastern United States through the first week of July. The southeast is the area I am most concerned about from a public health standpoint, because extreme heat is landing on top of already flood-damaged infrastructure and a population that is still dealing with the impacts of Tropical Storm Arthur. Heat exhaustion and heat stroke risks are significantly elevated in communities that are without power, that are cleaning up flood damage in the sun, or that are displaced from their homes. Looking to days 6 and 7, Sunday, June 28th and Monday, June 29th, the heat holds across the south while a trough approaches the Pacific Northwest. That trough brings cloud cover and potentially showers to Washington and Oregon, but will not quickly end the fire threat. Fuels are far too dry for brief moisture events to do much. Across the central plains, that same approaching trough may trigger organized severe thunderstorm activity across the Dakotas and Nebraska by late Monday into Tuesday, June 30th. The SPC will be watching, and so will I. But now I want to take you into the big picture, because what we are dealing with this week is not just a series of independent weather events. There is one massive signal driving all of this at once, and here is where it gets really interesting, and I will show you exactly why in just a moment. To understand why wildfires, flooding and record heat are all happening simultaneously across different parts of the same country, you have to step back and look at the atmosphere at a planetary scale. What we are watching right now is a pattern that long-range forecasters and climate scientists have been warning about for months, and it all traces back to one signal that is intensifying in the equatorial Pacific at a pace that is genuinely alarming even the most experienced forecasters in the field: El Nino. Not just any El Nino, but what ECMWF, NOAA, the Australian Bureau of Meteorology, and IRI Columbia University are all projecting to be a potential super El Nino event. NOAA's Climate Prediction Center officially issued an El Nino advisory on June 11th. The Nino 1+2 region in the eastern Pacific is already running at plus 2.1 degrees Celsius above average. The Nino 3.4 region, the primary monitoring zone, is at plus 0.7 degrees Celsius. IRI Columbia University assigns a 98% probability of El Nino conditions persisting through the remainder of 2026. CPC gives a 63% probability of this becoming a very strong event, with sea surface temperature anomalies exceeding 2 degrees Celsius during the November through January peak period. The ECMWF is projecting SST anomalies of plus 3 degrees Celsius by December, with some ensemble scenarios pushing past plus 4 degrees. NOAA's CFSV2 model is telling the same story. The Australian Bureau of Meteorology is telling the same story. 3 independent modelling centres from 3 different continents are in agreement. This is one of the strongest and fastest developing El Nino signals I've seen in many years. The subsurface driver is a massive oceanic Kelvin wave propagating eastward across the equatorial Pacific with temperature anomalies of plus 8 degrees Celsius at depths of 50 to 250 metres. As that subsurface heat rises to the surface over the coming weeks and months, it will fuel surface anomalies that could approach or exceed the record set during the 1997-98 Super El Nino. For context, the ECMWF and BOM 2026 forecasts are both developing faster than those same models were developing at this same stage in 1997. That is a sentence that deserves a moment to absorb. So how does this Super El Nino connect directly to what you're seeing outside your window this week? The connection is extremely direct. El Nino's strengthening subtropical jet stream is pumping excess moisture out of the warming tropical Pacific northward into the southern tier of the United States. That anomalously moist and energized atmosphere is what allowed Tropical Storm Arthur to produce 31.56 inches of rain in Cottonport, Louisiana, in a single day. You do not get that kind of rainfall without a fully saturated, deeply unstable, moisture-laden atmosphere. El Nino is part of the moisture engine that enabled it. At the same time, El Nino amplifies upper-level ridge building over the western United States during summer. That mechanism is what produced the March 2026 heatwave that shattered records across 14 states, and it is what is building the ridge pressing down on Seattle and Portland right now. This is the same atmospheric machine, running continuously through the year, expressing itself in different forms across different parts of the country at the same time. I want to spend a moment on what a Super El Nino event means for the rest of this year and into 2027, because the implications go well beyond any single season. When El Nino events reach the super threshold, sustained anomalies above 2 degrees Celsius in the Nino 3.4 region, the downstream effects become dramatically more extreme and more widespread than in a typical moderate event. The 1997-98 Super El Nino produced catastrophic flooding across California, devastating drought across Indonesia and Australia, record-breaking hurricane activity in the eastern Pacific, and significant disruption to global food production. The 2015-2016 Super El Nino produced the worst coral bleaching event in recorded history, devastating droughts across eastern and southern Africa, and some of the most extreme precipitation events California had seen in decades. Both events fundamentally reshaped global weather patterns for 12 to 18 months. What NOAA, ECMWF, and the IRI Columbia University plume are all pointing to right now is an event that could rival or exceed both of those. The Eastern Pacific Nino 1+2 region is already at plus 2.1 degrees Celsius in June, month before the typical November to January peak. The subsurface heat anomaly of plus 8 degrees Celsius at depth means there is an enormous reservoir of energy still to be released to the surface. Every month between now and December, that warmth will be rising and amplifying the surface signal. The ECMWF is showing plus 3 degrees Celsius by December. Some ensemble members push past plus 4 degrees. If those numbers verify, we would be in territory that is literally extraordinary in the modern observational record going back to 1950. For the United States, the practical implications run through every season. This coming winter, December 2026 through February 2027, the CPC is already flagging a high probability of above normal temperatures across the northern tier and wetter than normal conditions across the southern tier. That means more atmospheric rivers for California, more ice storms and heavy rain for Texas, Louisiana, and the Gulf Coast, more snowfall suppression across the northern plains and Great Lakes, and given the current drought footprint across the southwest, even a wet El Nino winter may not be enough to fully recharge groundwater and reservoir systems before the fire season of 2027 begins. The IRI Columbia University plume assigns a 98% probability to El Nino persisting through the remainder of 2026. When the world's most respected climate modelling centres reach that level of agreement on a single outcome this far in advance, you take it as close to certainty. This event is happening. The only question is how strong it gets, and the trends as of this morning point consistently upward. The Atlantic hurricane season is where El Nino gets the most public attention in terms of long-range forecast shifts. CSU lowered its 2026 forecast on June 10th to just 11 named storms, 5 hurricanes, and 2 major hurricanes, down from 13 in April. NOAA projected 8 to 14 named storms with a 55% chance of a below-average season overall. The main development region across the deep Atlantic is running cooler than normal. Upper-level wind shear from El Nino is tearing apart any convective organization before it can become a named storm. This is exactly what you would expect from a developing Super El Nino. Before we wrap up, there is one more thing you need to know, and this is the part I've been building toward throughout this entire video. El Nino suppresses the deep Atlantic. It does not suppress the Gulf. And what I see in the Gulf Basin right now is a completely different story. Water temperatures in the Western Caribbean and across the Gulf are running above average. The northeastern Gulf, that corridor from the Yucatan through the Florida Straits and northward toward the Gulf Coast, is sitting in water that is well above average for late June. El Nino's wind shear signature is weakest in the Gulf region because the upper-level flow is less direct, and the distance from the primary shear source in the subtropical Atlantic is greater. Multiple recent model runs, the GFS and the ECMWF, have been flagging a period of interest in the 7 to 10-day time window. A wave organising in the Western Caribbean or moving across Central America into the Gulf could find a narrow window of reduced shear combined with very warm sea surface temperatures in this period. The European ensemble mean has been showing enhanced low pressure in the Western Caribbean and Southern Gulf Basin in the 8 to 12-day range. GFS ensemble members are flagging the same period. This is consistent with a seasonal transition pattern in which the upper-level high temporarily shifts westward toward Mexico, briefly reducing shear across the northeastern Gulf and opening a window for potential tropical organisation. I am not forecasting a hurricane. I want to be absolutely clear about that. What I'm telling you is that the window is real, the water temperatures are supportive of development, and the Gulf Coast needs to be paying attention for the next 10 to 14 days. If you are in coastal Texas, Louisiana, Mississippi, Alabama, or the Florida Panhandle, places that are still dealing with flood damage from Arthur, the possibility of another moisture event on top of what you have already experienced is something you need to be tracking. Even a weak tropical system that enters the Gulf in this window will be moving over some of the most saturated, flood-vulnerable terrain in the country. The flooding potential from even a modest system would be extreme given current soil moisture conditions. This is the key takeaway from everything I have covered today. We are not dealing with a series of independent weather events. We are dealing with one coherent planetary scale atmospheric forcing, a developing super El Nino that is simultaneously building heat domes over the western United States, pumping excessive moisture into the southern tier, enabling catastrophic flooding, feeding extreme wildfire conditions, and shaping what could be a pivotal tropical season for the Gulf Basin specifically. This pattern is not going to release its grip quickly. NOAA's CPC outlook shows above normal heat most likely across the entire western United States through July, August, and September. The subtropical moisture pump will remain active across the south and southeast through the same period, and somewhere in the Gulf or the Western Caribbean, there will be more opportunities for tropical development before this season ends. Drop a comment right now and tell me your state, your city, and which of these three threats, fire, flooding, or heat, is the one your community is most focused on. I read every single comment and your answers directly shape where I focus tomorrow. Hit the like button if this detailed breakdown is what you come here for. It genuinely helps more people find this channel during exactly the kind of active multi-threat pattern we're in right now. Make sure you are subscribed with notifications on. Tomorrow I will be watching two things very closely. First, the updated National Interagency Fire Center fire weather forecast for the Pacific Northwest, because the combination of offshore flow, above normal temperatures and single-digit humidity creates one of the most dangerous fire weather windows we've seen all year, and any ignition in that environment could become catastrophic quickly. Second, the 7 to 10-day tropical model guidance for the Western Caribbean and the Gulf Basin. If the signal that GFS and ECMWF are showing sharpens overnight, I will break it down for you in full detail tomorrow morning, before most channels even start paying attention to it. That is what we do here. Stay safe, stay informed. I will see you tomorrow.